Hello, Algebra 2 folks, and welcome to Solving Continued. We are going to spend another day talking about solving. But my question for you today is, what if the equation is already in log form? Well, guess what? That's called a logarithmic equation. So yesterday they were in exponential form, and they were called exponential equations. And so now they're in logarithmic equations because they're in log form. You're going to need your calculator, a pen or a pencil, and some notes, and we will get started. So the first thing we need to know is, what do we need to solve a logarithmic equation? Well, you're going to have to know those properties of logarithms, expanding and condensing properties. You're going to need to know how to change to exponential form. So this says log base 4 of 16 equals 2. That's the same thing as 4 squared equals 16. So we've got to be able to get into exponential form. And we have to be able to do that even if we see an ln. So ln is the same thing as log base e. So log base e of 2.72 is equal to 1. Then if I want to rewrite that in exponential form, I would have e to the power of 1 is equal to 2.72. All right, so those are the two things that we need to know in order to be successful today. We also need to know that there's two types of log equations. Just like there were two types of exponential equations, there's two types of log equations. One is that there's logs on both sides, and the other one is that there is one log, and it's only on one side. And we're going to treat each one of those types of equations differently. So let's go ahead and try a few examples. So, first of all, logs on both sides. Let's think about making things equal. So if there's a log on both sides and they're both to the same base, I can set these two things equal to each other. So 4x minus 7 is equal to x plus 5. Add 7 to both sides. I get 4x equals x plus 12. Subtract x from both sides. I get 3x equals 12. Divide by 3, and I get x equals 4. And now what I'd want to do is just make sure that this is going to work. So I'm going to plug 4 back in for x. So log base 5. 4 times 4 is 16 minus 7 is 9. And does that equal the same thing as log base 5 of 4 plus 5, which is 9? That checks out. Remember, this number right here cannot be a negative number. So we want to always check to make sure that this number right here is not a negative number. So we do need to check our answers today. All right, now that's if we have logs on both sides. What if we have logs on one side? So what we're going to do is we are going to make sure that our log is isolated, and then we're going to change it into exponential form. So how do I know if a log is isolated? I need to see the log, the base, and then what's right after that. And as long as it's not in parentheses, or if it's in parentheses, then it is isolated. Everything else around it should be gone. So this says log base 10 of x is equal to negative 2. I'm going to go ahead and rewrite it in exponential form. 10 to the negative 2 is equal to x. I'm going to plug that into my calculator. Oh, look at there. And I'm going to get 1 over 100 is equal to x. All right. I'm going to make sure that, if I can, I'm going to use fractions, if at all possible. Okay, so I'd always try to make sure that the problem is in fraction form, or the answer is in fraction form. If you can't, then you can just approximate. But that would be the same thing as saying log base 10 of 1 over 100 is equal to negative 2. And as long as that is a negative, we shouldn't have a problem. Let's try another one. This one says 7 plus log base 10 of x equals 4. All right, I need to isolate the log. Oh, I've got this extra little 7 over here I need to get rid of first. So I'm going to subtract the 7 on both sides. I get log base 10 of x equals negative 3. Rewrite it in exponential form. That would be base 10. Exponent is negative 3, and that equals x. And 10 to the negative third is the same thing as 1 over 1,000. So 1 over 1,000 is approximately the answer. And I could type that in to my calculator, verify it, and also knowing that that is not a negative, it should satisfy the equation. Okay, let's try another one. It says negative 3 plus 2 ln of x equals 5. Okay, I need to get that ln of x alone. That means I can't have anything being multiplied by it, nothing being added or subtracted. So the first thing I'm going to do is I'm going to add the 3 to both sides. I get 2 ln of x equals 8. And then I want to get that ln of x alone, so I'm going to divide by 2 on both sides. I get ln of x equals 4. Ln of x is the same thing as log base e, remember? And then I can say e to the 4 is equal to x. I can plug that into my calculator, and e to the 4 is 54.60. And that's what x approximately equals. All right, and I can type that back into my calculator, negative 3 plus 2 times ln of 54.6, and I should get approximately 5. All righty, let's do another one here. This one says log base 3 of 3x, and this time the 3x is in parentheses here, so we got to keep that as part of the log. That doesn't get separated until the very end. So I can go ahead and rewrite this in exponential form because I know the 2 is the exponent. So 3 squared equals 3x. 3 squared is 9 equals 3x. Divide by 3, and I get x equals 3. And 3 squared does equal 3. 3 times 3 is 9. So that does check out. X does equal 3. Okay, let's do another one. Again, this whole thing is a part of the log because there's parentheses. So I'm going to go ahead and rewrite this in exponential form right away. 2 to the 5th power is equal to x minus 6. 2 to the 5th power is 32. X minus 6. And I add 6 to both sides. And I get 38 is equal to x. If I plug that back in, 38 minus 6 would be 32, and 2 to the 5th is definitely 32. So 2 to the 5th is definitely 32 by using your yellow sheet and having that handy. All right, we'll do one more example here. Now, this is where we're going to have to use those properties of logs. Remember last week when we were doing properties of logs and we had that plus sign? We can condense this into one log. So we can say log base 4 of x times x plus 12 because the plus sign means a product. And that's equal to 3. So now what I can do is I can rewrite it in exponent form. So 4 to the power of 3 base power is equal to x times x plus 12. I can go ahead and multiply that through. 4 to the power of 3 is 64. And x times x is x squared, and x times 12 is 12x. And now I have a quadratic equation. This is a quadratic. And how do I solve a quadratic? Remember, I have to set it equal to 0. So I have to say 0 is equal to x squared plus 12x minus 64. And how do I solve a quadratic? I either need to use the quadratic formula. Okay, so I either need to use the quadratic formula or factor if possible. Oh yes, factoring. Factoring has come back. So what are 2 factors of negative 64 that add up to be 12? I believe that's x plus 16 and x minus 4. I said each one of those factors equal to 0. And I get negative 16 and positive 4. And I should always check my solutions here. So I'm going to put the negative 16 back up into the original. Remember, we always go back to the original, and that would say log base 4 of negative 16. I can't have a negative in that place, so right then and there, I know the negative 16 is not going to work. And the 4 should, because 4 going there, I'll get a 4, and 4 plus 12 would be 16. So be careful that. Make sure you check for extraneous solutions and cross out anything that is not going to work. All right, that's all I have for you today. That concludes solving um, exponential and logarithmic equations. And we'll see you tomorrow to practice them a little bit more.